Hi everyone, welcome to today's live webinar, 6 Essential Steps to Avoid Container Security Vulnerabilities. My name is Ryan McCurdy. I'm on the marketing team here at Lacework, and I'll be your moderator today. As we're getting started, I just want to give you a couple housekeeping items. This webinar is being recorded and will be sent after the event. It's also meant to be interactive, so please ask any questions using the Q&A box. Also on the right hand of your screen, you should see some great content following the same lines as what we're talking about today, which is container security. You can download that and take it with you. So without further ado, let's get started. With me today, I have Brian Bernstein, our security engineer here at Lacework. Brian, over to you.
Thanks, Ryan. As we jump into this, remember, feel free to ask some questions as we go through. I'm happy to turn around at the end and answer those questions for you guys. Now, I'm sure we have all read or heard from someone that just try to justify that containers are just secure as they are. It typically goes along the lines of, hey, almost nothing runs in the containers except for the essentials, so really what's the problem? Or I don't actually store any real data in my containers, so there's nothing to really get compromised. One of my favorites, though, is, well, even if my container gets compromised, I'll just kill it and restart the container. What I think is really funny about that is I don't then always hear them say, let's figure out how it got compromised, and let's figure out how to fix that before we put that container back into production. Seems like they go hand in hand, but they don't always. Another one I'll typically hear is, my container doesn't run long enough for anyone to do anything. That whole let's be really quick so people can't get in, security by speed, I guess. And then another one that I typically hear is, the host doesn't have any external access, so if they can't get to the host, then I'm not really too worried about it. We'll just continue operating. Well, in a perfect world, that'd be great. Well, even in a perfect world, those excuses to not build security into the platform itself can really backfire on you. What I want to go into now is just talking about some real-world issues that we are seeing with containers. So there's this idea of a container escape. It sounds like a scary word, right? Well, it is actually kind of scary. Container escape is a vulnerability that allows you to escape from a container and get access to the base host itself. Think outside of the box here. This is definitely the biggest concern since containers have really started to become mainstream. When we're thinking Docker, this absolutely can apply to them. The biggest concern here is obviously now we're taking your access from a container, bringing it to the host. This can happen from misconfigurations as well as exploits. The actual resources from the host are being shared with these containers, and they're not in fact full sandboxes. They're sharing connectivity and all of its resources through the actual host that's running those containers. So now this isn't just something that's theoretical. Let's talk about an actual example of one of these vulnerabilities. Now what we have here is CVE 2019-5736, and if you're not familiar, CVE is a Common Vulnerabilities and Exposure. This is a standard framework for listing out vulnerabilities that exist out there and explaining what they are and what they affect. But essentially this vulnerability is a vulnerability that allows you to escape from that container into the actual host file system. This was the first major container escape of its kind. It was announced back in February. Basically what they're doing is they're using a specially crafted container to overwrite the RUNC binary and allow them to run code arbitrarily. And RUNC is what Docker uses, and that is the most common containers out there. So really it's a concern of, are we running this implementation of Docker that allows for this vulnerability? Now, if you go out there and search, there is some real code out there that shows you how you can do this. And what we're actually seeing here is, on the bottom is the victim machine. They've gotten one of these containers that are exploited, they run it, and then what you saw on the top was the attackers sitting there with a listener on their machine, and when they launched that container, what you're seeing is that attackers actually getting a session to the host system of the person being attacked, of the victim. From that point, what you saw at the end there is really scary. Not only do they have root access, but that root access is again to the host system. So you got to really think about what's happening here, where now this user is able to get access to the host system, and now if you're running a large system with multiple containers with multiple different microservices, we're no longer just talking about a compromise of that one single container, but since they now have host access, they could theoretically get into all these other containers and all these other microservices that you're running on that single host. So you might think, well, that's great, but how could this really happen to me? I'm not going to deploy some, compromised container onto my host. Well, you got to think about, where are you getting your containers from? Is trusted software can be compromised. These common vectors can come from things like repos, third-party applications that you might be using, or maybe even some other open source project that you pull down. The example I like to say here is this isn't anything new. This has been happening in the security world for a long time. And let's take a really popular example from a few years ago. If any of you remember the exploit called Xcode Ghost, basically what would happen here was there were some hackers that took a version of Xcode. They modified that version of Xcode, and sorry, Xcode is a development platform for Apple applications. And they were able to basically make it so when somebody uses their exploited version of Xcode, it injected their code into the applications. Now, this happened very commonly in Asia, where some really large apps that were very widely used, what they were doing was they were downloading this false version of Xcode, which was embedding this code into their applications, and then that was getting posted on the App Store. Now, people were downloading these apps and apps that they absolutely trusted from very reputable developers, and they were actually being compromised by this code that's been embedded. It's not that different from what we're talking about here, and if it can happen to a company as large as Apple, what makes you think it can't happen to these other developers that you might be using within your images? So I'll stop being complete doom and gloom and focus on some of the good parts of this. How can you avoid using these compromised images? First step obviously was going to be build your own images everywhere you can. So if you're building your own applications, your own scripts, just embed those. Don't immediately go to a third party for something that you can do in-house. There's absolutely reasons that you would need to use a third-party image, such as the base OS. Make sure you're using the official images and not some side project that you don't really know what it is. Even if it has some appealing feature, really vet where you're getting those from. Your repos that you're storing your images in, these are critical. Make sure you have really good access control around them, dual-factor authentication if you can, because again, just like most things in this world, if people get access to authenticate to your repository, they can modify your images, inject things into your images, completely replace them. You really don't know. So you got to really control who's able to get it in there and modify and upload images to your repository. Next thing is to scan your images. So do you have vulnerable versions of particular things within your, of applications within your repository, within your images, that should be remediated before you make use of them. Use least privilege. This is common across all security things within your integration tools. Don't give it rights to things it shouldn't have, just what it needs. And also verify those images that you are downloading. Don't just assume that because you downloaded this image from some place that it is in fact the official image that you'd expect it to, so making sure that you have the right one. Be very wary of how open source projects are maintained. I think a lot of us are probably big fans of open source projects. It's the way the world works. We get some great applications out of that. But just be aware, how are they maintaining, how are they vetting the changes that are being put into their projects? And then finally, if possible, especially when we're talking more of a corporate environment using applications from other vendors, if it's possible, go ahead and understand how they are protecting themselves, how they're putting controls around the development process and deploying their images that you're using. Now, specifically talking about the escape mitigation, of course, you're always going to want to follow best practices to minimize the chance of the escape. Just like we were talking about in the previous slide, there's some other things you can look at. Don't run privileged containers if you don't need to. They get access to a lot more than a standard container would do. Use read-only file systems. Another thing to understand is, yes, 0 days are very rare, but the fact that they've never been seen before make them extremely difficult to actually detect. So when any vulnerability is uncovered, make sure that you have a really solid plan in place on how you update your images, how you update your base hosts, your base nodes. Have that plan ready so when there is a fix available for any of these new vulnerabilities that come out, you have a strategy in place to go ahead and address those problems. Now, just because there haven't been enough issues brought up yet, I will bring up one more, and then we'll shift to how we can help bring back some power to ourselves and help further solve these problems. But now we have to think about containers in the cloud. With these new modernizations of how workloads are run, it is very common that the shift makes its way to modern platforms, such as things like AWS, GCP, and Azure. Now, when talking about deploying in places like that, there are some great advantages that can be gained by running in that cloud platform. There are also some new avenues of attack that are introduced by using these platforms. We saw one of these attacks very recently through the breaches such as the Capital One. If you have access to query the AWS metadata server, then you also have the ability to run commands within the AWS infrastructure as if you are the role that's attached to that instance. So let's think about this for a second. There's this ability within AWS with all the hosts, so this does include the containers, that you can query this local IP address. Now, this IP address lets you find out things about, tags on that host, users, all this different metadata information about the host that it's running on. Now, what this also includes is the current credentials that are assigned to that system via its role. So what they're able to do is you can query that, pull these credentials down, and basically act as if you are that role that's attached to that host itself. So what this means is that that role doesn't have least privilege and it has too many rights. You're able to start doing things like maybe accessing S3. This one's really scary, but what if that role had IAM rights? If you have IAM rights within AWS, you can do almost anything you want. So it doesn't matter how short-lived that container might be. If that person has those credentials, even if they are temporary might mean 4 hours, there's a lot that they can do within your account. And this is very similar to what we saw within Capital One, where they were able to get those credentials and start doing other activities within there based on the access that they have. Now let's also tie this into the orchestration tools that you might be using. We see by default, a lot of these tools will actually store their credentials and their configuration files within, say, an S3 bucket. Well, obviously some concerns is the security around that S3 bucket correct? Do you have that bucket publicly facing so everyone can see your configuration? Or in the example I just gave, has somebody hijacked credentials so now they're actually able to view those configurations? So now they have access to your cloud infrastructure as well as to your actual workload infrastructure as well. So just some additional things to think about when you're deploying these tools within a cloud environment. Now I'm going to transition a little bit and talk about how we over here at Lacework see the world. This transition from the well-defined borders of on-premise have now shifted to a blend of resources stretched across many different platforms in many cases. It is hard to keep track of where all of your resources may exist and be operating. On top of that, you have more and more groups getting involved in deploying and administration of these platforms. On top of this, it is all happening at a pace that we have not seen before. That is why we believe that the best way to address this is to treat the problem like a big data problem, taking large sets of data and using new generation architecture to intelligently build machine data to automatically discover issues across your environment. As you can see from the examples data set, in a 30-day period, and this is actually from one of our customers, we collected 7.65 billion pieces of data. Now this data can be things like processes launching, user activity, files, basically all this stuff that goes around how your workloads actually operate. From that 7.65 billion pieces of data, we then boil that down to 37.5 million entity behaviors. Now just think of that as this is what an independent processor or user might be doing. The other way that you can look at this is over this 30-day period, via an automated fashion using our machine learning, we automatically built 37.5 million rules. This is the size of a rule set that you would need to now find new activities, or as we like to say, anomalies within your environment. From those 37.5 million entity behaviors, we then boil that down even further to 1.93 thousand events. And these are just things of interest that have happened that we automatically correlated for you. Now, again, if I said, okay, that's great, let's send that to an analyst, and that analyst has to go through 1.93 thousand detections over a 30-day period, we might think that's overwhelming and we actually can't deal with it at that scale. But that's not where we leave it. We also take into the kind of activity, have we seen this before, is this internal, is this external? We take in all these factors to help build out a severity behind this. And that's where you're seeing, and across most of our customers, this is very common because we're only looking at the true anomalies for the environment, is you actually got 32 higher critical events within this time period. So this allows you to really focus on the true problems, the true anomalies within your environment that could be indicators of a compromise. Now, how do you really build this level of intelligence and security into your environment? It starts at build time. It might be pretty obvious. You must embed security directly into the development process. It is not enough to bolt it on after nowadays. To keep up with the DevOps, you must also automate as much into the process as you can. It's no longer acceptable to add in major roadblocks that's going to slow down and prevent DevOps from doing what they need to achieve. Finally, these tools must integrate into the same workflow that the devs are used to using. I mean, again, really think here, guys, if you're waiting until after something's been released or it's been running to add security or figure out how to do security solutions onto it, the problem's way too late. It's already passed you by. We need to figure out how to embed it in and how to do it in a way that the dev teams will be able to utilize it and accept it and help them advance their purpose. Next, you must be looking at the technologies that are actually hosting your applications. For the purpose of this talk, we're going to just focus around containers, but of course this will go into VMs, physical machines, whatever else you might be using, but we'll stick to containers for now. And this goes back to a lot of the points we were talking about earlier. You have a way to identify vulnerabilities in your containers. Have you used trusted images? Is the principle of least privilege in play, and do you have a strategy around storing the activities from these containers? These are all really big problems that are hard to solve because all of this is happening at a very rapid pace at a very large scale. Now we made it to the actual runtime. Are there tools in place that understand an ephemeral environment that is always changing while giving you automated alerts? How confident are you that the detections you have will not miss unknown attacks? Are the alerts that you're receiving even at a level that your team can manage and process effectively? How do you enable your security staff to focus on real security issues and not just spending time maintaining rule sets and trying to figure out how to identify what is next before it happens? And I've touched on a lot of this, but it's really this idea of how do you get visibility back into this very ephemeral, constantly changing, constantly moving environment? It's not the same as before where we understood our normal workflows, they change, they're very static. Things are constantly changing. The visibility is getting harder and harder as we extract it more. How do we bring all that back? And how do we detect things that we don't even know are going to happen? That is why here at Lacework, we believe that it's critical to have a platform that allows you to operate as a platform across this entire life cycle, providing constant feedback in this loop. For the rest of the presentation, I'm going to focus on how Lacework helps you solve the issue around vulnerability management, workload and container security, and even security of modern tools such as Kubernetes. So we're going to focus on 6 essential steps from how Lacework sees and what we do around it. The first is going to be scan for what vulnerabilities exist within your repository. Second is understand where in your environment your containers are actually deployed. Next is going to be knowing what processes containers are running. The fourth is have a baseline of what process communications communicate to and from. Next is going to be monitor the infrastructure that hosts your containers. And then finally, we're going to look at how you can have the ability to investigate containers that may not even exist anymore. So again, Lacework is a solution that can help solve some of the hardest workload and container security problems, deploying host intrusion detection, runtime security for containers and Kubernetes, as well as build time with container vulnerability scanning. This results in insights that allow you to better understand the environment, discover threats, and take a forensic investigation look. So let's actually look at what some of these look like now. So first, here what we're looking at is a vulnerability assessment dossier. The way that we're doing this is we are actually integrating into the repositories themselves. From there, we pull down these images, and we're going to investigate them layer by layer to see what CVEs they have in them. Some of the things that you'll notice on this is under the containers column in the bottom right there, you'll see a couple of numbers. Now, you'll notice some of them have 1. This can go up. What this is actually telling us is how many instances of these containers are deployed within your environment. You know, you might have a repository that could have thousands of images. How do you figure out what you should patch first? Well, maybe obvious, but patch the ones that are actually deployed. You don't want to spend a whole lot of time fixing containers that aren't even being run anywhere. You want to focus on those containers that are widely deployed and in use. The other great insight that we have here is, all right, we've got some critical vulnerabilities and we have a total number of vulnerabilities. Well, are there fixes to those vulnerabilities? That can also help you figure out, should I be jumping in here and running these updates? Again, like I said previously, have that plan in place when there is a CVE published. How do we go about updating these within our production environment? Diving into a specific image here, what you're going to see is now you can obviously sort by the level of severity. We might not care about those informational and low, maybe even medium ones, but of course we care about the critical and high ones. What you'll see is we actually show you layer by layer how that was introduced, and then even the command that introduced it. From there, you can drop down. You'll get a description of what the vulnerability is, and then you'll also get the vectors of attack based on the CVSS scoring. This is, again, a great way to understand, is this something that I really need to care about? If it's a vulnerability that requires local access, or this is an application that's buried so deep inside my environment, that can help you figure out, do I need to prioritize this or not? And then taking it back to what we were talking about before is getting the visibility into the environment to actually understand where are these containers being ran. Because it's also another great thing to know that they're being run, but on what host, which system is actually running this. And this is just a snapshot of one of the cards that can help you understand that. But you can start diving into these particular containers and really understand, what repository were they from? What host are they on? Are they being deployed in Kubernetes? What namespace are they running in? Really getting that data that can sometimes be hard to track down, especially if you're deployed across multiple clouds, different environments, that central repository to figure out where everything is and get that look into where everything is actually running within your environment. It's kind of the idea of taking that complexity and kind of simplifying a bit, because complexity can be a very difficult thing to work with in security. So the next thing we're talking about is knowing the processes that containers are actually running. So again, it's great. You build a container, it has certain applications, but then what are those applications doing once the containers are actually running? So this is some really important insights, especially if we start turning up some of those anomalies that I was talking about earlier. Why did that happen? Why is my container running differently? Also, one thing on this is we store all this data for 180 days. So this is really some great source of information on how your containers are running at any given time. It gives you some really strong insights and visibility back in the containers without having to sift through logs, jump around to different places to figure out what's happening here. Now, the next one is talking about having that baseline of what's normal for your environment. So, as I mentioned, Lacework is basically building context around how your processes are communicating. What this means is we're looking at a process itself, we're watching what network connections it gets and then what it connects to, and then we're building those behaviors I talked about with the machine learning and building this view here. This is basically a full workflow that we're seeing a connection come in from external into this Nginx application, into HA proxy, which then connects to this container, and then makes some resources flows. The important thing here is because we're doing this at the process level, we don't lose visibility on what's happening here. We can see when those containers are talking to other containers, see that going to external communications, internal communications, stitch all that together and understand what is normal. So if somebody all of a sudden hijacks that container that we have there and then just phones out to a new IP address, we'll know that that's not normal behavior for your environment and give you those great insights that I was just talking about, such as, what processes were running, what was the command line arguments, what did they communicate with, so you can really get that information. Again, think ephemeral environments here. This could happen very quickly. That container could be gone. How do you know that that happened, and then how do you go back and look into that? Another very important thing, like I said, working within the tools that your dev and operations are working in is understanding them and giving visibility into them as well. What you're seeing here is our Kubernetes dossier, and this is now giving the specific visualizations and context of Kubernetes, and this can actually be searched across our platform. If you want to start looking at pods, namespaces, clusters, whatever it might be, you can build filters and searches based on that. But what you're actually seeing in this view is, here's a graph of all the connections and what clusters are connecting to, and then what are those clusters communicating with. I can then take that view down to namespace and show you a very similar thing, and then ultimately take that down to the pod level and show you what actually are your applications communicating with from inbound and outbound, and really give you that strong view. A great thing about this also is, you really don't want things like your Kube API exposed to the internet. Maybe you think that that's not happening, that you're not getting direct connections from the internet. But with a tool like this, it's going to bring the visibility in so that you can see that, and not across a single cluster, but across all of your infrastructure to understand if there is, in fact, connectivity coming in and out of places that maybe you don't expect. And again, if that starts happening post our baselining and understanding of your environment, you will always get automated alerts on that. The next part is, again, we're talking a lot about infrastructure, but let's not forget, there's those special considerations that I talked about when talking about cloud infrastructure. So what we're actually seeing here is an AWS example where we've collected CloudTrail logs, and what we're showing you is what are all your user service and roles doing within that cloud environment. So on the far left, what you're seeing is what accounts are logging into my accounts, where geolocation are they logging in, are they using API? In this case, that's what you see. If it were web console, you would see that as well. All the principals, all the users, services, and roles. What regions are they accessing? What is the actual service within AWS that they're calling? The API call of that, and then ultimately the result of that API call. So let's go back to that example where we were talking about somebody hijacking a role from earlier. We're baselining all of this activity so we know it's normal. So if somebody, logs in from a new location, they access a new service, a new region, make a new API call, even the result of that are all different vectors that we're using to help find anomalies within the environment. So if somebody breaks into that container, they're able to query the metadata server, they pull down those credentials, and now they start poking around to figure out what access they have, or they access a new region and maybe spin up some new instances to do illicit Bitcoin mining, or access S3 that they've never accessed before. That's all going to be anomalous, and we're going to let you know that that's happening. So again, think of this as host intrusion detection for the platform that your containers are running on. Now here we're taking a look at the ability to investigate containers that may no longer exist. And I know I've talked about this a lot, but now getting more explicit into it. Again, the idea is these containers might not exist anymore. So when you do know that something anomalous happened, how do you really get into the details of, what process was it? Where was it being run? Maybe even what user, or who did it communicate with, on what port? All this is really critical information that if all you have are things like VPC flow logs, are impossible or at best very difficult to get. Where here we're having that all correlated for you in one spot with things like what pod was it running, what was a container, what was a repo, obviously this really deep critical information to help you quickly deep dive and figure out what's going on, even for those containers that don't exist anymore. And I mentioned this before, but you can also go back 180 days. So if you get a report or somebody wants to know how a container was behaving, even 4 months ago, you can go back to that and see the same information. And this probably isn't a surprise either, but like I was showing, even diving into what was the processes that ran at that moment, not maybe what's currently running in there, but what actually happened at that moment that the container was in use that you were concerned about. So it's all about those insights, expediting investigation, and really understanding, getting visibility back into your containerized environment to help deal with some of these really complicated, difficult threats that we talked about in the beginning. I appreciate you taking the time to join us today for this conversation. Cloud and containers have issues to consider, but they also have a lot of advantages. It's just all about understanding what these risks are and having controls in place to help you mitigate them. Ryan?
Yeah, thanks, Brian. That was a great presentation. We had a few questions come through. Now is a great time to, if you have any questions, please submit them via the Q&A box. So let's just dive right in. So the first question that came through is, when do you update your CVEs?
Yeah, so the vendors themselves update CVEs typically daily. So we do a daily pull for new CVEs and update all of the images with any new CVEs that might be published for those images. And then, of course, the new the new images that you create will be checked for any new CVEs as they come in as well.
Thank you. How does Lacework detect Kubernetes deployments?
Yeah, so the way that we deploy into Kubernetes is we use the native deployment, kind of the point of an orchestration tool. So we have the native YAML files. We just deploy as a daemon set within your clusters, and that gives us the visibility into all of the data that I was showing you before so that we can show that to you.
We get this question often, although I don't know if you mentioned it on this webinar. How do you do runtime container security?
That's going to be very similar to what we're doing in Kubernetes. Again, we're use the native tools that are available. We deploy as a daemon privileged container essentially within that environment that lets us get visibility into all the other containers. So it's just a matter of deploying us to the host, and we'll be able to run and get visibility into the containers there.
Where is the data processed?
So another great thing here, especially when we talk about shifting to the cloud, is we are a SaaS offering. So all of the processing is done in AWS currently in US West 2. But what's important about that is we don't require you to deploy any infrastructure or servers within your environment. There's no point where you have to, stand up a server, have that be the processing for you. We have these agents that we deploy. It's going to stream that data back to our data warehouse, and that's where we're going to be doing all the processing for you. No concerns about how do I scale my environment, what if my server goes down that I have to host myself. All of that's shifted to us, and we take care of that for you. Also within the repository scanning, again, we're natively logging into those repos through read-only access that you've assigned us, so that we can do that examination on our platform and not requiring you to pull those images down further to do that investigation.
Great. And thank you, everyone, for submitting your questions. We're starting to get quite a few come through. How do you guys get the process visibility of my container?
Yeah, that's going to be, again, pretty much the same conversation we just had, running as that privileged container that lets us see the actual, what's happening inside the containers from that visibility, from the agent that we're running.
Okay. And this is a great question. Which vulnerabilities do you see exploited the most?
Yeah, no, that's a really good question. I think in the container context, it's still pretty new. Just back in February was that first real container escape vulnerability that was put out there. But the same problems that normal applications have, containers problems have as well. So whether it's bad code written for your web application that somebody's able to do, like the SSRF attack that I was talking about before, where they can make that local request, or even the version of your web server that you have deployed within that container. So it's not just about the container vulnerabilities themselves, But that's why we say it's so important that you're scanning the containers to figure out what vulnerabilities you have within those other standard packages that you're deploying like you would in any standard VM. So, I mean, I can't say it's, one particular type of attack. I think it's more just to say, keep in mind that those problems that you had don't go away just because you're running them in a container. Great question, thank you.
How does your alerting work, and do you work with Splunk?
Yeah, absolutely. So we don't try to be an island on ourselves. So what I mean by that is we want to, take in this data and send it out to the normal workflows that you already use. So all of our alerts can be sent out through many different integrations. Splunk is absolutely one of them, but includes things like Slack, PagerDuty, ServiceNow. We also do support webhooks, so if you want to build out a custom platform that way, or we also have a pull API. So if you want to build out custom scripting, build remediations or playbooks around our alerting, you can absolutely do that.
Perfect, thank you. How long does it take to establish a baseline?
Yeah, so we're going to watch everything as it comes in. What happens is it's called an unsupervised machine learning model, so you don't have to give it feedback. It's just going to watch what's happening and automatically update itself over time. So every new hour, we do a batch process that looks at all the previous behavior, looks for new behavior, alerts you based on the new behavior. But then as it continues to see that alert, obviously if it's benign, you'll do nothing about it. It will automatically tune itself to those new activities. Now, typically what we say is there's about a 5-day period of initial deployment, and then of course if you make any major changes to your environment, you might get a large volume again. But typically about 5 days is what we see to start getting a pretty well-established baseline.
Are you seeing very many attacks against Kubernetes clusters?
Yeah, there's a lot of interesting stuff going out there. Again, this is all a lot of new technology, so there was a pretty recent CVE published for Kubernetes out there that had to do with the API server where essentially you could downgrade and there was a way to basically do communications outside of the standard HTTPS communications. There was also a default basically bootstrap interface that was just no auth, straight HTTP that was being deployed by default. A lot of times people wouldn't turn that off or orchestration tools wouldn't turn that off. So those are obviously two really interesting ways that your Kubernetes cluster can get compromised. I don't have any hard numbers off the top of my head on how often we're seeing this in the real world, but there are definitely real things coming from it. And again, it's not just because there's a vulnerability in the code itself, but things like misconfigurations such as the deployment, the bootstrap thing. Those are all things that are actually happening that I'm sure people have unfortunately learned the hard way that was going on.
Great, thank you. And this will be our last question. You touched briefly on enabling DevOps. How does Lacework do that? Is it a feature set or architecture? What does that look like?
Yeah, so a big thing is obviously working within the tools that they're using. We have a lot of integrations, especially when we start talking about vulnerability management. How can we work in their build process to help them get feedback on if the images they're pushing have vulnerabilities? Additionally, the great thing about the way we're doing this is the level of visibility that we're giving and the way we're addressing the problem is in a language that is the language that the operations and the development team is going to work at. We're not just saying that, hey, a bad thing happened. This looks like X attack, so that your security team goes back to them and says, hey, fix this bad thing. We're saying, no, we saw this activity from this process, did this exact thing, and it's a common language that everyone can speak, so you can have these intelligent conversations and help get to the core of the problem. And again, not just say, oh, we got compromised, let's just redeploy the container. Let's actually understand what happened in that container, speak to the operations, speak to the development team, and figure out how you can work together to help solve those problems and not getting in their way because, again, it's going to deploy in the tools that they're using and they don't have to put up a bunch of roadblocks that they have to figure out how to get around.
Great. Thank you, Brian, and thank you for presenting today. Everyone on the line, thank you for attending. Again, there's content on the right-hand side of your screen under the resources section. Feel free to download that and take it with you. We'll be following up with the recording of the webinar. So once again, thank you for your time, and we'll see you at the next Lacework webinar. Thanks. Bye.